Assalamu alaikum students. Today's our topic is going to be about fluid friction and Stokes law. Let us read about it. Fluid friction occurs when adjacent layers of fluid, liquid or gas are moving at different velocities. The fluid depends upon the viscosity of the fluid and relative speed between the layers of the fluid. That means if there's layer of fluids like this, an object is passing through that fluid, these molecules inside the fluid basically stop this particle in its way. So this drag which is happening because of this fluid is known as drag force. Let us read about it. When an object moves through a fluid, the fluid exerts a retarding force that tends to reduce the speed of an object. This retarding force experienced by an object moving through a fluid is called a drag force. The moving body exerts a force on a fluid to push it out of the way. By Newton's third law, the fluid pushes back on the body with an equal and opposite force. If we have an example, let's say put our hand out of the window of the fast moving car, shown as the existence of fluid friction and the drag force that a fluid exerts on our hand moving through it, just like this. When we put, let me remove the lines. When we put our hand outside the window, the wind basically blows it back because of the drag force in the opposite direction. So this is the concept which they are trying to tell us about the drag force. The drag force depends upon size, shape, orientation of the object, that how was the hand placed, it was parallel or perpendicular to the air resistance, the property of the fluid, that what kind of wind was there, it was smoggy, it was clear, the speed of the object relative to the fluid, the car moving basically fast or slow as compared to the air moving outside. So all of these characters matter. The viscous drag force on a spherical object is expressed mathematically by a formula termed as Stokes' law. Consider a figure. According to Stokes' law, a drag force D depends upon the radius, the velocity, the spherical object, and the coefficient of viscosity, which is eta, of a medium through which spherical object is falling. It depends upon three things. First of all, viscosity, which is eta, r, the radius, and v, the velocity. Here it is, the radius, the v velocity, and the eta through which it is falling through. If we put a constant value in it, which is A, then Fd, that means drag force is equal to A eta RV, where A is the constant of proportionality and it's experimentally determined as 6 pi. A is equal to 6 pi, therefore putting in the values of 6 pi in the following equation, what do we get? We get Fd is equal to 6 pi eta RV, which is known as Stokes' law. This equation, first set forth by the British scientist Sir George G. Stokes in 1851, is termed as Stokes' law. Stokes' law finds application in several areas, particularly with regard to the settling of sediments in fresh water and in measurements of the viscosity of the fluid. I hope you enjoyed today's topic. Inshallah, we'll meet again. Allah Hafiz.